Guys, Easy Science here, Michael here, making some new videos for you guys. Like I said, I'm going to be making more videos from now on. So today's topic, let's get right into it. So today's topic is molecular forces. Just wanted to talk about that. I feel it is important to talk about. Because molecules, as we know, are held in. If they weren't held in any way, they would just fly apart and run. We can't have that. So that's why there are molecular forces. There are different types of molecular forces that I'll explain today. So let's talk about the first one, intramolecular forces. Intra meaning between molecules and atoms and stuff. So it's basically the force binding atoms together to form molecules. An example of this would be, let's say we have an atom here. Oh geez, that's a bad pen, my bad guys. So we have an atom here and an atom here. To make it a molecule, there has to be some force pulling them together. That would be the intramolecular force. Now there are three types of intramolecular forces. The first being covalent. So actually there are bonds that can form. So intramolecular forces are basically bonds. So there is covalent bonding. There's also ionic bonding. Okay, and then the last one is metallic bonding. So let's go over the first one, covalent bonding. Covalent bonding is basically, as there's metals, nonmetals, and metalloids. So for this one, covalent bonding is with nonmetals and nonmetals only. I guess metalloids can count in this section. So one thing is nonmetal plus nonmetal. The bond is how a bond forms. So let's say so like in this example, there's a hydrogen with one lone electron. As we know, to make an atom stable, it has to have full valence. So the last shell, the valence shell, has to be full. And that would satisfy the octet rule, which states that if there's 8 valence electrons in the shell with the proper energy shell, it will be stable. In this case, it's in the first energy shell, which is first electron shell, and it has 2 electrons in there. To make it stable, it would need 1 more electron. This is where another hydrogen right here comes in to the other hydrogen and says, hey, I have another hydrogen electron. Do you want it? Or we could share it. So by sharing it, they basically both have it at the same time circling around, and that electron makes both of them stable, as both of them basically have 2 valence electrons and 2 valence electrons, making it stable. And that is how covalent bonds form. I could get into more detail, but that's basically the gist of it. Likewise, ionic bonding. Let's take a look. So like right here, there's a sodium atom and a chlorine atom. A thing to get started with before, ionic bonding is only with metals and non-metals. Unlike covalent bonding, this one is different. It includes, as we can see right here, the energy is needed to take away the electron. Let's say for example, we see that in the sodium has 3 energy shells. We have this one, and this one. On the third one, there's only 1 electron spinning around. This is just relative, but this is how we picture it. There's 1 electron spinning around. And to satisfy the octet rule, as we can see, there are 8 valence electrons in this one. But what would be easier? to get 7 more electrons to satisfy it. So in this shell there would be 8, so it needs 1 plus 7 equals 8. Or remove an electron to get this shell that is already formed and to make it formed. And that will make it satisfy the octet rule and be stable. Much easier to just lose 1 electron. In chlorine there is, in the last one, 1, 2, 3, 4, 5, 6, 7. To make it stable, it needs 1 more for 8. So that's when chlorine meets sodium. And chlorine says, hey, I need that 1 electron. Just please give it to me. And sodium does not want the electron. So like, hey, I'll give it to you. And to give it, they have to attract to each other. So basically in this case, sodium finds chlorine, gives its electron away, and by giving it, they become into a bond. So then this would become an ion, because ion is an atom with a charge. Since this one lost it, it would have a plus charge. So it has less electrons. This one would have a negative charge. This one will have a negative charge. So that's how it will work. And this bond is very, very strong as a bond. Usually the compounds formed are salts. That's what they're usually called because it is with a nonmetal and metal. And that sodium chloride, or sodium and chlorine, is a very good example of salt, which is, it is salt. So salt is a good example of an ionic bond. Next one we have up is metallic bonding. Now the last one, metallic bonding. Metallic bonding is kind of cool because, like, as we know, most metals have a positive charge. Basically, all of them have positive charge as ions. And because of their extra electrons that they have, whenever they're in contact with other metals with the same thing, it's usually formed with the same metal or in an alloy with that metal. So when it is formed, there is basically a mass sharing of electrons happening. So as we say, there is like all those electrons floating around, and in between them they share them to satisfy the octet rule. So it's basically like the covalent bonding that we saw, but with metals. Only metals, just metals. The type of metallic bond formed determines the properties of the metal, such as lustrous, the color, the strength, tactility, malleability, thermal properties, ductility, you name it. Okay, now we are switching gears a bit. The second molecular force is intermolecular forces. These forces are basically forces between molecules. They act as if we, like everything, all the atoms, molecules have some sort of repulsion and attraction. These attraction and repulsion create the intermolecular forces. There are 3 types of main forces for intermolecular. First one is London dispersion forces. Okay guys, so right now I'm going to have to explain quite a bit. So each molecule and atom can have a polarity. Polarity is just a word for having a charge, just like our Earth has 2 poles, North Pole and South Pole. Each one has also a pole. So right here, delta, this symbol delta, that's a bad drawing, just means what charges. If it's delta minus, electric negative charge, delta plus positive charge. Right now, as atoms go, they have electrons inside, which spin. But when they spin, it's not clear, like, it's not just following a pattern. It's random, very random. At some points, all of the electrons spinning can end up on one side. This would create more negative charge on one side than the other, which that side becomes negative, other side becomes positive. This can happen for another thing. This is why it has a delta negative symbol. If we cross this in half, this side has more negativity than this side. So this side is then negative. If this side has less negativity, it is positive. Same thing here. So in this case, if there's positive and negative, this creates a slight electrostatic attraction. Electrostatic attraction is attraction between negative and positive charges. So simply, it's like a small magnet is created. The positive side and negative side attract. But this is very weak and lasts for very instantaneously, like very quickly. So this is one of the weaker intermolecular forces. The second intermolecular force would be Dipole-Dipole Attraction. Actually, forces. So, what I mean by this is, you probably need a background check. Oh yeah, this video is going to be a bit longer than I expected. So, these two examples right now are basically the same but drawn differently. This one's more like 3D looking. So, there is something called electronegativity. The definition of it is basically like what's it called? An atom's power or tendency to attract electrons in the bonding pair. What that means, more simply, is, let's say here, this is water, H2O, 2 hydrogen, 1 oxygen. Oxygen has a high electronegativity. So in the atom, let's say they're all connected, the electrons, and this is a covalent bond, like we saw here, non-metal plus non-metal, it'll be sharing electrons, so they're both shared. But since they're shared, they're not always equal. In this case, since oxygen has a high electronegativity, it has a tendency to pull electrons toward itself in a bonding pair. So here, the electrons being shared, like it goes here, 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 spins around these guys. More or less, it will be pulled toward the oxygen side. So instead of being there, it will be like here, right here, instead of right there, so instead of the middle. So I mean, it's that. So the delta again, like we know, I mean slight charge. So because it's the electron is more on the oxygen side, because of its stronger pull than hydrogen has, this oxygen side was going to be negative. So it's going to become a dipole. Dipole is like pole, so dual pole. So this is a dipole. Since pole means polarity and like a pole, this is a dipole, 2 poles, negative pole and positive pole. Same thing here. So dipole-dipole forces. If these are found just floating around like in water atom, what's it called? So like in water, let's say I have a glass of water, lots of these molecules. Dipole-dipole forces will be there. Instead of them being gases, because intermolecular forces basically keep things from becoming gases. Because in a gas, there's only London dispersion forces, and that's not enough to keep it from being liquid or something. That's why it's a gas that flows around everywhere. A liquid is a liquid because of these dipole-dipole forces. So the same thing there, like in London. Since there's a negative here and a positive here, there will be some electrostatic attraction between them, which would pull them closer in. Instead of being a gas spread apart and everything, they will become closer. This is stronger than London dispersion forces, so it would make it a liquid. Or just make it move less. Like in this case, it will be a liquid. Now the last type, here I'll give you another example. So hydrogen bonding is a bond formed, not a bond, but a force, intermolecular force, which is basically a dipole-dipole force, but with hydrogen and something else. This is the strongest intermolecular force. This intermolecular force can only occur with atoms in the bonds. So like right here, this is the big atom besides hydrogen, and like these ones, they have to be the same or others. it is one of the strong electronegative elements, such as nitrogen, oxygen, or fluorine. In this case, we have oxygen, highly electronegative, very strong pull. So because of its electronegativity, and it's very high, because it's more slightly negative than this, that one's slightly negative, this one's slightly positive, the hydrogen from other atoms will make a bond, like shown right here. Will make somewhat attraction, but it's going to be strong, stronger than dipole-dipole, with the highly electronegative oxygen, basically making a liquid because it's going to be stayed together closer. Hydrogen accounts for like the unique properties of water. It also has applications in other things, but that's why hydrogen bonding is the strongest, because in research it is shown that bonds with hydrogen in it are more strong than other bonds. That is how we know. Okay guys, thank you so much for watching. So let me give you a bit of a summary. So we learned about intermolecular forces and intramolecular forces, which are both part of atomic or molecular forces. And intramolecular is basically between atoms and atoms to create bonds. And intermolecular is between molecules and molecules to keep them somewhat in place. Alright guys, thank you again for watching. I'm sorry I haven't been making too many videos. I will for sure make them. Please leave a subscribe and a like if you like this video. Comment down for any other topics you would like. Alright guys, Easy Science out.